Hello and welcome. This is Lab 5, build your DB server and interact with your DB using an app. I'm Richard Golson, and let me take you through the lab overview and the objectives. So in this lab, we're going to reinforce the concept that we've been discussing about leveraging AWS managed resources, in this case, a database instance that's going to solve our relational database needs. Now, if you recall, we've seen how we can deploy a database to an unmanaged EC2 instance, meaning that we will take on all the management tasks for that database and the EC2 instance. So we're updating the operating system. We have to, and patching, we're also updating and patching the database management engine on there. And those are not necessarily easy tasks. So by leveraging AWS managed resources, we're letting AWS take on those tasks for us, as well as the scaling. So with RDS, it makes it very easy to resize our capacity. So at any time, we can improve the capabilities of our RDS instance and the database running on it by increasing the amount of CPU and memory that's assigned to our RDS instance very easily with just a click of a button, as well as increasing the capacity of the elastic block storage volume. So that makes it very easy to set this up and deploy and manage. So if we take a look at the tasks in the lab, by the end of this lab, we're going to be able to launch an RDS DB instance with high availability. That means that we'll be deploying both the primary and a secondary or standby instance. We're going to configure a DB instance to permit the connections from the web server to the RDS instance, and we'll be able to open a web application and interact with that database with that web application. If we take a look here, we can see that we begin with a configuration for our VPC, includes, for high availability purposes, 2 availability zones with public and private subnets in both availability zones. They've also deployed in that lab environment a NAT gateway to provide ingress and egress traffic, or egress and ingress traffic from our databases if need be, as well as a web server with the application server running on there. Let's go take a look at that as well. So if we take a look, here's our VPC, and you can see that we have both the public with a route to the internet gateway and both availability zones, and the private subnets with a route to the internet through the public subnet gate, or the public NAT gateways, and out through the internet gateway. We look over here at instances, where you see there's our EC2 instance, and that's configured with a security group that's going to allow traffic on port 80, HTTP, and port 22. So it's going to allow both web traffic and secure shell traffic. In this case, we'll only need the web traffic. We wouldn't actually need secure shell management. Also note that on the details tab, it's been deployed to that public subnet 2, as we can see in the diagram there. And it has a public IPv4 address that's reachable from a web browser. So if we take a look over here, we can see that before we even create an RDS instance, an application is running on there with form fields that allows us to make the connection between our RDS instance and the application server that's interacting with it. Now, in the course of the lab, we will complete this infrastructure by deploying an RDS instance in both the private subnet 1 and private subnet 2. If you take a look over here, we can see that we have a subnet group that we're going to build or create, and that's a resource that identifies for RDS service where it should deploy our RDS instances. And so you can see it identifies the 2 availability zones and the 2 CIDR blocks or subnets. And if we take a look here, here is the first one, here's the second one. So we know that our RDS instances will deploy to those subnets. The other piece to this that we need to create in advance is the security group. So if we take a look at the security groups, we can see that Here's that web security group that's allowing that port 80 traffic. We saw this earlier. Here's our database security group that we will assign to our database. And you can see that that's allowing port 3306 traffic from our web security group. So this is going to allow our application, the application server, to interact with the database. That security group is going to allow that port 3306 traffic. That's query traffic from the web server. So all traffic from the internet that would flow from the EC2, the application running in the EC2 instance, will flow to the application server, and then the application server would interact with the database. Now, going back over to our RDS instance, take a look at the logs here. You can see that in the creation of our DB instance, it's also been modified to convert it to what's called a multi-AZ DB instance. So we're using more than one AZ, we're using two. And remember, one of those will retain our primary instance, the one that is read-writable. And then we'll have our secondary or standby instance, which is updated by the primary. This allows for failover. If our primary fails, RDS service in the background will switch traffic from the primary to the secondary in the background. So we won't even see a configuration change because the way that RDS targets these instances. So rather than applying an IP address for the endpoint, RDS actually uses something a little different. So let's take a look at the configuration. And here you can see the connection details that we will provide in the form fields. And you can see under the connection details, it includes the username for the EC2 instance. So that's, in this case, we're using main as the username, and the master password, lab.pass or -password. Here's the endpoint. And note that the endpoint points to the RDS service on Amazon AWS. It'll send it to that API. And you can see that right here is the region. And then here is the unique string for that endpoint and the name of our DB instance, which is LabDB, which is not the same as the database running on there. That's actually the database name, LabDB. So you'll be naming your instance LabDB. What AWS does is if our master goes down or primary, in the background using DNS, AWS modifies the host record for our database and changes the IP address that identifies or connects the endpoint. And so the IP address that is related to this endpoint, which would be in this private subnet 1, would be removed, and the private subnet 2 IP appropriate address for the secondary would be related to the endpoint. So then traffic would just flow to the secondary and no longer flow to the primary. So that's how they use that. And so we'll be using those connection configurations, and we can see that that information is also available here. Excuse me, here's our LabDB. And if we take a look over here under connectivity, we can see that that connection information is here. And then on the configuration tab, we can see the name of the instance and the DB name. And then if we come over here, AWS makes it very easy for us because we can also see that information. So all of that information is going to be available to us, and ultimately we'll fill this in. And when we do and submit it, we'll make the connection and it builds us an address book. And at that stage, we could then begin interacting with the address book by adding new contacts. I won't complete this completely. I'll just put some values in here. Excuse me. And I'll submit it, and we can see get a new contact. And then you could look and say, oh, wow, that contact's not accurate. Let me remove it. And now I've tested the connection between the application and the database. And so I know all that works. So that's it for this lab. When you're done, you'll have an address book all set up. You'll be able to interact with it. You want to make sure you test it. and then make sure you run the grading script and then make any changes as appropriate. But that's it for our lab. I think you're really going to enjoy working with this. You're going to find it's very interesting. And there are many, many additional options when you build the RDS database. So take your time to take a look at those as well when you get done. All right. Thanks for watching, and we'll see you in the videos.